Okay, so in front of us we have a Sapphire RX 6800. This is the Nitro Plus. This card was sent to me by a customer who asked how to repair it. So, like all the broken cards we get, we want to first start by checking for a short on the base voltage rails. So we're going to go to the continuity mode, and in continuity mode, if I probe something connected to ground, like ground itself, my multimeter beeps. So, to start with, we're going to check 12 volts and 3.3 volts at the PCI Express slots. If you don't know, the first 3 pins are 12 volts, and we're perfectly good. And to check 3.3 volts, we start this notch and we go 4 pins left. And we're perfectly good. Okay, now we want to check 12 volts at the external 8 pins, so we want to be checking after the fuse. So starting with the one on the right, we're perfectly good, and moving on to the left, we have a short. Okay, so we have a shorted card, unfortunately. So right off the bat, I can tell you that this is probably going to be a MOSFET, given that this is the most common cause of a short on 12 volts. But anyways, let's go to resistance mode and check regular resistance mode and check the voltage rails generated by the card itself. So, to start with, we're going to check, there's actually 3 5-volt rails, by the way. So this is one 5-volt rail, 7.5 kilo ohms, perfectly fine. And this is another 5-volt rail, 4 kilo ohms and rising, perfectly good. And this is the other 5-volt rail over here, this LDO, 2 kilo ohms, perfectly nice. Okay, now we want to check 1.8 volts. This is 1.8 volts here. So as you can see, above a kilo ohm, so that's good. And I think this is the PEX rail, the 750 millivolt rail, 22 ohms, perfectly normal. So, and actually no, now let's check the memory and memory controller. So I think this is the memory hold on, let me move this. Okay, like I mentioned, I think this is the memory controller here. And we have 20.7 ohms. Okay, so now let's check the actual memory itself and not the memory controller. This is the memory controller, by the way. 0.23, maybe this is the V-core, or hold on. No, okay. So this is our memory, and we have a short on the memory rail, which explains our short on 12 volts. So now let's check the SOC. So it's the bottom 2 inductors here. I'm not going to remove the pad because I'm worried it'll tear apart, but checking this bottom inductor, actually no. In order to check this, we actually need to check the resistance of our probes first, given the SOC rail has a very low resistance. So we have roughly 0.15 ohms. Okay, now let's check that SOC rail, and we'll subtract 0.15 ohms. So we have about 2 ohms, so that's perfectly normal too. So we have a short on the memory phase. This is generally not a good sign. Typically speaking, when the MOSFET, or power stage in this case, goes short on the memory rail, it kills the GPU and all the memory. I just want to note that there's a mistake that I keep making in this video. So during the video, you'll notice that I say that the memory phase connects directly to the memory and the core. On this particular card, and a lot of AMD cards in general, the memory phase does not connect directly to the core, so only the memory in this case is at risk. But anyways, so we have to confirm that the, well, first we want to confirm if the GPU and the memory is alive. We can't do this with our shorted power stage, and I'm assuming it is a power stage. So what I'm going to do is I'm going to hook up my power supply, and we're going to perform a basic test. So, I have my ground probe on ground, of course, and what I'm going to do is I'm going to hook up about 0.7 volts to our shorted 12-volt rail, and what I want to see is whether it passes to the inductor or not. And the reason why is because sometimes these power stages, they either short to ground itself, or they short to ground through the memory and the GPU. If they short to ground through the memory and GPU, you can assume that the memory and the core are dead. But if they're not shorting to ground through the memory and GPU, then this card might actually be savable. So anyways, let's hook it up. Oh dear. So anyways, just so you can see this. So as you can see, the card is taking 0.7 volts and 9.05 amps. That's quite a bit. Okay, so like I was saying, what we're going to do is we're going to check the voltage on the inductor. If you don't know, these power stages and MOSFETs, they sit between the 12-volt circuit and the respective outputs, you know, the V-core or the memory or whatever. They're not supposed to just pass voltage across from, 12 volts to the GPU itself. What I mean to say is that sometimes when these power stages or MOSFETs die, they just pass whatever voltage they're fed straight to the core, or in this case, memory. Okay, so since I'm feeding the card 0.7 volts on the short 12-volt rail, what I want to see is whether we have 0.7 volts on the memory phase itself. If we have 0.7 volts on the memory, we can kind of assume that when the power stage died, it sent 12 volts to the memory. So, checking the memory MOSFET, we have 100 millivolts. That's actually low enough that the card might be alive, though I don't want to get too hopeful given what I know about graphics cards. Anyways, so there's only really one way to determine this. So what I'm going to do is I'm going to lift this inductor, or actually no, I'm going to lift both of these inductors, and this will tell us which power stage is bad, and also it'll tell us whether we have actually have 0 ohms on the memory. Okay, so as you saw, I lifted the inductors for the memory phase over here, so you can now see the first inductor pad. So what we're gonna do is we're now gonna first. Okay, so the first suspicion, of course, is that the core and the memory are dead. So what we're gonna do is we're gonna check the resistance of the memory and core itself. So remember, before we had 0 ohms. If we check now, we have 20 ohms. So which is actually a pretty good sign, given that the this is Samsung memory and 20 ohms is normal, so I'm not going to say that the memory itself is alive, but this is looking rather optimistic. Okay, now we need to confirm which MOSFET or power stage is short. Let's go to continuity mode. So let's see if we still have a short on the 12-volt rail. We should. Yes, we do. Okay, now what we can do is we can just check these 2 inductor pads. So checking the bottom inductor pad, nothing. But checking the top inductor pad, short. So that tells us that our faulty power stage is actually the one up top. So as you saw, so we have 20 ohms on the memory, suggesting that the memory is good, or at least I hope the memory is good. And we now can confirm that yes, it's this power stage that said. So I'm going to go ahead and replace it, and hopefully the card will just work. Okay, so as you may have seen, I replaced the power stage. So I've used a TDA21472, as this is the model that's actually used on the higher end versions. The RX 6800 XT and the 6900 XTs. But it is compatible. I've also reattached the 2 inductors, and I've replaced the fuse off camera. So anyways, let's go ahead and boot the card. Okay, 1.35, that's good. But notice that you can't just assume that because you replace the power stage that it works. You need to confirm this. So we're gonna measure the switching frequency. These power stages, they should have a switching frequency of 500 kilohertz. So that's what I expect to see. Yep, 502. So yes, it is powering on and it is working as intended. And better yet, we have a BIOS splash screen. If you're wondering why the image looks corrupted, it's because I have a non-UEFI motherboard and it gives problems with modern AMD cards. But in either case, let's put the cooler back on and let's see if it does actually work, as there is a high chance that we have a dead memory module. Okay, so as you can see, the card is running game. It's been running game for about an hour now, which is long enough, I think. So if you look at the bus interface, it's X16 as it should be, and the clocks and temperature and power consumption is actually, it's all a little low, but that's because my computer can't push the card fully. I'll admit that this was not too educational. This was a very straightforward basic repair, but in either case, I do hope you learned something, and hopefully I'll see you in the next one.